The moon. It's been our faithful companion for 4.5 billion years. But did you know it's actually leaving us?
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
Right now, as you watch this, the moon is drifting away at a rate of 3.8 centimeters per year. That's about the speed your fingernails grow. It sounds like science fiction, but we know this for a fact thanks to the Apollo missions over 50 years ago. Astronauts left behind suitcase-sized mirrors called retroreflectors. We still use them today. By firing powerful lasers at these mirrors and timing the bounce back, we can measure the moon's distance down to the millimeter. So why is it leaving? It's all about gravity and the oceans. It's a cosmic dance of tidal forces. The moon's gravity pulls on Earth's oceans, creating a tidal bulge that stretches towards the moon. But here's the catch. Earth spins much faster than the moon orbits. We spin once a day, the moon orbits once a month. Because of this fast spin, friction drags the tidal bulge slightly ahead of the moon's position. That heavy bulge of water pulls on the moon, giving it a gravitational tug forward in its orbit. In orbital mechanics, if you speed something up, it goes higher. This energy boost pushes the moon further away. Let's rewind the clock. If the moon is moving away, it must have been much closer in the past. 1.4 billion years ago, the moon was huge in the sky, and Earth was a very different place. Back then, a day wasn't 24 hours. It was only about 18 hours long. The Earth was spinning much faster. Think of a figure skater. As Earth loses energy to the moon, it slows down, just like a skater opening their arms. We still feel this braking effect today. Earth's rotation slows by about 2 milliseconds every century. Going back even further, for 0.5 billion years ago, the moon formed from a massive collision. When it first coalesced, it was just 15,000 miles away. Today, it's 238,000 miles away. Imagine the tides back then. With the moon so close, waves would have been thousands of feet high. These massive tides might have actually helped kickstart life, mixing chemicals in ancient primordial pools. The moon does something else crucial. It keeps Earth steady. It acts like a cosmic stabilizer. Without the moon, Earth would wobble wildly on its axis, causing chaotic climate changes. Just look at Mars. It has no large moon, and its axis tilts erratically over millions of years. So, what happens in the distant future as the moon keeps drifting? In about 600 million years, the moon will be too small in the sky to cover the sun completely. Total solar eclipses will become a thing of the past. We'll only have Ring of Fire eclipses forever. Days will keep getting longer. Eventually, a day on Earth could stretch to hundreds of hours. But will it ever truly leave orbit? Will we lose our moon entirely? Theoretically, no. Eventually, Earth's spin would slow down enough to match the moon's orbit. This is called tidal locking. Earth and moon would face each other permanently, locked in a long embrace. However, the sun will likely expand into a red giant long before that equilibrium happens. So the moon will stick with us until the very fiery end of our solar system. To recap, it's moving 1.5 inches a year. It's slowing down our days, and it's changing our future. Next time you look up at the night sky, remember, that familiar face is slowly waving goodbye. As our days get longer, even by milliseconds, it makes you wonder about time. If you could have a 30-hour day, what would you do with those extra 6 hours? Sleep or explore? Let me know in the comments below. Thanks for watching, and as always, stay curious.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.